vindicator. It wasn't written about, but it was pictured. All right, so like I said, my name is Mark Calautti. I'm the biomedical option of the group. Just a little bit about me. Past 2 years I've worked as an intern at General Motors, and I'm going to continue my employment there when I graduate with a full-time position.
Michael Slavens, I'm the computer digital option electrical engineering major, and I have a position lined up at ABB up in Wycliffe, Ohio, cybersecurity division.
My name is Ryan Melichar, also an electrical engineer, the traditional option, and upon graduation I will be working for First Energy as a substation design engineer. So basically what we're doing here, like Mr. Caden said, we're making like a ground drone. Mainly the reason we want to do this is because we like robots, and why not? Because you know what, they're cool. So that's the main aspect of why we want to do this. So what our goal was to make like a tank-like type vehicle that can traverse various terrain, both indoor and outdoor. And we want to do this wirelessly using 2 motors and a wireless IP camera to give us sound and audio. And what we also wanted to incorporate in this project is, as you've seen in the news and everywhere, 3D printing is becoming huge. So we wanted to kind of grab that technology, bring it into this, because YSU is starting to get big with it. And even here in Youngstown with American Makes downtown, so it's a really big emerging field. So initial concepts. This, believe it or not, this monstrosity was our initial design. This is what we were going to use to make our robot. As you can see up top, there is the scuba tank, which goes to show that the robot used to walk like a spider, and it ran on pneumatics. So we were going to take that off. We were going to add a wheel to each of the 6 legs, and add 4 independent motors, 2 on each side, and it was going to look kind of like a moving type, like a car almost that moves. It was also, we had the potential to carry a heavy load with this. We talked about maybe carrying a person. But we ran into some problems with that later, as I'll get into. The problems, there was actually a limited amount of problems with this design. The first one was the initial frame of the robot had a few pinch points on the outer edges, where if you were to put any type of load onto that, it was going to fail ultimately. So that was one of our main problems. Also, you saw how big that thing was. It's huge, and for our purpose, the portability of it is going to be a major problem. So we didn't want to have to deal with moving it, carrying it, especially with the scuba tank on back. Weight becomes an issue. Also, the budget was not adequate for our design. In order to get that design to work, we were going to have to spend way over the $300 allotted amount using the heavy motors we're going to need, and also the various wheels to move it. So we completely abandoned that idea. Probably the first weekend we knew it wasn't going to work, and we had to hurry up and think of what else can we do. So, like I said, we're going to do a custom design 3D print for our body. This image here was done in SolidWorks, and that is a rendered design of our final product. So we used a 3D printer to create that downtown in American Makes. And so once we have the body, we needed some type of motor. So we decided to use smaller DC power motors out of a cordless drill. The benefits of the design was that it was completely customized. So it was tailored to fit our needs exactly. We didn't have to work around, pieces of machinery or pieces of our design coming into play where we'd have issues. Also, it saved us a lot of money by retrofitting it. Like I said, taking drill parts, something you wouldn't think of as how a robot, it saved us money in the long run. And also, the size was a huge issue. This is like, the size of a briefcase almost. You can pretty much carry this around anywhere you need without having any major issues of weight or any other thing like that. And I'm going to hand it off to Mark, and he's going to talk about our opportunity statement.
All right, so you kind of saw the initial concepts that we came up with. So the problem or the opportunity that we're solving with this tank is that, through our 4 years here, being an IEEE, being in student government, we're missing opportunities to impress incoming students. Like the STEM Showcase is a great opportunity for high school students to come in and check out the projects, but that requires the high school students to want to come out on a Saturday afternoon and want to walk through. With our design, we feel that it's portable and it's easy to use. We can take it to the schools. There's been some pretty strong initiatives since President Tressel came around to get out to local high schools, talk to kids, let them know what's happening at YSU, what they can do. and this is something that they can take along. And like we said, it's a robot, it looks cool, it's in camo, it's got a camera on top of it. It's got certain wow factors that kids in high school that are into that kind of stuff, you know, that really draws their attention. So obviously when we did our design, we wanted to identify our customer needs. Our customer is going to be the YSU STEM College, the STEM Outreach Program. So we needed to take what they wanted to see, some parameters, like I said, ease of use, portability, wow factor, and kind of incorporated that into our design. One of the more important things as far as functionality was sizing the motors and the batteries to meet our desired or set speed. This is something that Dr. Calautti really stressed with us, is making sure that we had parameters that we needed to meet in our design, because you can't just go out and just throw things together and hope it works. So we wanted this to kind of represent a walking pace. So average walking pace anywhere from 2, maybe 3 miles per hour. And as we look into further applications, a walking pace would be very suitable for military applications, especially if this rover, this lightweight rover, would be used to go into dangerous areas where there might be some mines in the ground or something. This would allow you to, you know, go through there at the pace of the soldiers. Then we wanted to design the body to hold the motors. Once we figured out what kind of motors and what kind of batteries we needed, we were able to design the motor to fit it perfectly. So that's where the 3D printing came in. Also to make sure that we had enough room for, you know, terminal strip, breadboard, Raspberry Pi, and those things. Then after we figured out the size and the components we needed to create the circuit. So this was drawing back from our experiences in sophomore, junior year. We needed to create the circuit so that we could power the Raspberry Pi, power the motors, power the controller, the camera. So there was a lot of power consideration for this project. And then finally designing the Python-based application. Like other groups have said, using the Raspberry Pi requires learning Python. That's where Michael Slavens came in. He's our computer and digital option. I don't think he knew too much going in, but I know he knows a lot more now after all of our testing. And then, of course, lastly in the design were the assembling and the testing, which is by far the most frustrating and longest part of the whole process. So our project timeline. As you can see, the first week or so was gathering information about our different concepts, starting with the big six-legged robot and moving towards the 3D design. A lot of these deadlines early on were met. Designing the 3D model, that was pretty early. Mechanical hardware, things we knew. The design application obviously developed as we went along. But as you get down to this area, these deadlines start pushing, everything starts pushing that way. But that's natural with the project. You run into things you weren't expecting. And so here's our budget. We were obviously given $300 like the other groups. We pretty much maintained that price, or that budget, under $300, thanks to some very generous donations. American Makes printed out our 3D body, which was would have been pretty pricey if we were to pay for that. It's a full body. It's like the size of a shoebox. 3D printing right now is usually only used for much smaller applications. You can see, you know, how we fit in there. All right, and then of course our intended customer is Youngstown State University. Like I've said before, we really think that we can help out the university and kind of give back by drawing students to YSU. There's a lot of good things here. There's a lot of great opportunities, and we feel that as graduating seniors, it's our job to kind of bring that back around and bring it full circle. So pass it on to Michael to talk about it.
Hello, guys. So, now the fun part. So here's where we came to the actual design. As Mark just stated, we did get the body 3D printed. We used SolidWorks to design it, and then thankfully, thanks to connections down at American Makes, we were able to get that printed out for free. So that's completely 3D printed, and as he stated, that did help a lot. As with any low-budget project, we kind of J-rigged some of it, and so we ended up using cordless drill motors. As you can see, we used two 7.2-volt drill motors. We took them apart, and that way we still had the charging circuit as well as the motor itself, made things simpler and easier, and still gave us the power that we needed. We did end up finding online, there's lots of robotics kits online. We were actually able to find this tank tread kit. It was relatively cheap, and we wanted to go with the tank treads. We thought that it would have be better able to go over different terrain. You know, you never know where it's going to be tested at, where it's going to be demoed at, and so we wanted to give it some flexibility. And plus, then we only needed 2 motors to keep it simple. And okay, so the brains behind it. We have a Raspberry Pi 2, which is the newest version of the Raspberry Pi. This controls the entire thing. It is the brains of it, as Mark stated. I did go into this overestimating my abilities and underestimating how hard it would be, naturally. So I had to learn Python. I had to do a lot of troubleshooting. So what it's doing is it actually has, on the Raspberry Pi, it's creating a Python. It's creating like a little server program in Python, and then on the laptop it has a client that connects to the server. And then it continuously sends the keyboard input, 1 character at a time, and then based off the key that's pressed, it moves different motors, does different things. So that's the basis of the controls. We also, in order to do pulse width modulation, we wanted to be able to do acceleration with the motors. It didn't work out towards the end, but in order to do the pulse width modulation, we needed more than 1 pin, because on the Raspberry Pi, for some reason, they only allow 1 pin to do pulse width modulation. And so, since we had 2 motors, we needed 2 outputs. So we got a breakout board. It gave us 16 pulse width modulation pins. And then it connected, I don't know how familiar you guys are, but it connects through I2C communication between the Raspberry Pi and this extra board. So you're able to control, theoretically, all 16 of those pulse width modulation pins, with just 2 pins from the Raspberry Pi. So it's a very nice feature. And then in order to give us video and audio, obviously you want to be able to see where you're going if you're wirelessly controlling this thing. We did get an IP home security camera, and that did give us, actually, went farther than what we expected. It actually has infrared, so we can do night vision, and it does do audio as well. So it can move and all that. And then we did get it custom printed. It's going to be a cool robot. It's going to look cool as well. So we got it hydro dipped. And you can see on the top, actually this body, where America Makes is, that was the part that was 3D printed down at America Makes, and then the top portion that the camera is sitting on, that was actually 3D printed here at YSU. So that's 2 plates that were 3D printed here at YSU. And those were the ones that were hydro dipped. So, as with any project, there are different potential conflicts. Obviously, if you're wirelessly controlling a camera that can move, there are potential privacy issues, depending on where you go, and if there are correct controls in it. We do have security obviously built in because it's on the laptop, my personal laptop, so I naturally have security built in. But it has an IP network that it's all communicating on, and so if somebody were able to hack that, you go back to IT security issues as well. And then obviously safety. You want to make sure that you can control the robot correctly. We do have some built-in safety features. If the incorrect buttons are being pressed, it stops. Simple things like that that help to ensure that safety is paramount consideration. And next steps. So, obviously, there are many things we could do. As everybody else has said, all the other groups have said, increase budget, we could use better parts, and make it so that it's not necessarily jerry-rigged together. We could expand the control system so that we could do more with that, obviously control it better. And then one thing that I initially wanted to do that wasn't able to come about is because of Linux driver issues that I had, I wasn't able to set it up with an ad hoc network. My ideal situation was where the robot and the laptop just had to be by themselves and communicating wirelessly between the 2 of them. Unfortunately, because of driver issues, the drivers are the two USB or Wi-Fi dongles we tried with the Raspberry Pi. The drivers that were made for them didn't support the ad hoc networks, that kind of communication, and I wasn't about to rewrite a driver. So we ended up instead we have our own little network set up. We have a router set up back there, and so it just communicates over that. So that is one future consideration I'd like to do, simply because that would make it easier for people that were demoing it and that sort of thing. That way they don't have to worry about setting that up and getting power to that as well. So things learned. we actually learned a lot about 3D printing. We hadn't really had any kind of interaction with it. We just knew that it was here. And so getting to interface with that and actually creating something from it was a really great learning experience. And even the potential challenges, you know, we first tried to print out the body here at YSU, and we found out the limitations that those machines had, which we never knew existed. So that was big. Obviously the Python coding, I already kind of complained about that. Didn't know anything about that going in. And then low-level networking programming, again, never done that before. I've taken 2 C++ courses here at YSU, and that's the extent. So that was a lot of learning experience. And then just motor control in general. We hadn't really done too much of that, and there were many different ways to do it. And so finally finding one that worked was a long process. So that's our project. Any questions?
What drove you to the 7.2 volt motors?
Well, we were considering a lot of things. One was the 7.2 volt motors had a lower RPM than like a heavy duty, like 19 volt cordless drill. So it was something that we could control a little bit better, more towards our speed. Size was also something, they were just a little bit smaller, gave us a little bit more room. And then the battery was probably the biggest. The batteries are just small little cells versus a big battery pack that, you know, is necessary to drive a higher voltage motor.
We weren't sure how we were going to control it initially as well, and so we wanted it to be able to go, but we didn't want it to be able to fly. So we thought it was a good balance in between. Thank you. Oh.
How much would it have cost if you had to pay to have that printed?
We were quoted
It was roughly
$950.
$800,000 to $1,000 out. They didn't use. There's different methods, like the ones YSU uses, how it's like the layer printed. The ones they use is one on the top of the line, it's like a 3D, not 3D, it was like a laser map, and then they shot powder with adhesives to it. It's actually way more sturdy than it needs to be. So it's quite nice, but very expensive.
And we didn't ask for that. They just
Thank you.
Thank you.